Okay. Hello everyone, welcome to ROS Workshops. This is going to be the first part of the four-part series I'll be presenting in collaboration with EESS and Robotics. And we're a team of aircon, and we're basically coming together across 2021 and potentially 2022 to put together a whole bunch of series. So earlier in the year, we had the PCB workshops, as well as the ROS workshop right now. We've got some amazing events planned out throughout the year as well as into next year that we'll talk about in just a brief second. I'll probably invite Daniel and Ryan from Robotics and EESS just to do a quick plug for their clubs as well. If you want to.
Yeah, sure. So I'm Ryan, president of the QUT Robotics Club. It's teaming up with the other project-based engineering clubs is going to work out great for everyone involved. Being able to teach everyone the skills that you need doesn't really touch on as well as they should. So the Robotics Club, we do a lot of project work, mainly focused on ground robots and arms. We meet every Tuesday evening, and we are looking at holding some series of workshops next semester, and we'll let you guys know what they are at the beginning of next year.
And I believe Daniel couldn't make it tonight, but we've got Margot who can probably do a plug for them as well.
Yeah, I'll do a plug for EESS. Hello everyone, I'm Margot. I'm the Chief Returning Officer for EESS, Electrical Engineering Student Society. We are probably one of the biggest education-based workshops. So we do a lot of work for, plus the new Vice President of the Robotics Club as well, as of 2 nights ago. So at EESS, we're very much a project education-based with a bit of projects as well. So we really work with some of the subjects that you're working on. So you're the big subjects that you go, I need some help with those ones. So that's really where EESS comes into it. So we're not so much big project-based, but a little bit project-based workshops just to help you get along with your assignments, so your CAB 202s, your 242s, your 120, for anyone who remembers how ghastly that one was, for your EESS mesh sesh coming up very shortly. So we really help with those sort of things, as well as providing electrical engineers, electrically based engineers, the opportunity to network and to socialize as well. We meet on a Wednesday night, usually in S9, along with all the other clubs. And yes, that's S. And thank you to Aerospace and Robotics Club for being part of joining us for this wonderful opportunity as well.
Thanks, Marco. And hi everyone, I'm president of Aerospace, and we run workshops every Thursday. We do everything from drones, now even rockets, into aircrafts and fixed wing planes. So we do electronics, avionics, as well as flying these planes and building them from ground up. We've got a big launch coming up next week. Hopefully lockdowns end and we can go out. It's going to be our first of the 3 rocket launches happening on 15th of August. So if you want to build rockets, come along next week. We've got a whole bunch of rocket workshops lined up, which they'll be teaching you how to build rockets from scratch and taking you out to the launch site. And we've also got a build a drone workshop coming up later into the semester, where we'll teach you how to build drones from scratch. These nano quads that you can fly around with FPV. Okay. So what's the plan for this ROS series? Currently, the plan is to put it into 4 different workshops. Okay. I'll go through the Ubuntu install as well, Ryan, so give me a couple of minutes. So what's the plan with the workshops in this series? We've got 4 workshops lined up. Today's workshop's mainly just the introduction and how ROS works in its sense. Next week, we're going to try and do some hardware. Hopefully, we'll be back at uni and we can teach you how drivers work, how hardwares work in ROS, followed by a more interactive computer vision / control workshop where we'll teach you why ROS is so powerful and why it sort of helps bridge the gap between hardware and software and why it's so popular in the industry. And then finally, the fourth workshop is going to be a bit more advanced on things like timing and scheduling, as well as services and things like that. So, why a lot of the big projects use it and how you can have like an entire swarm of robots following the same lead of robots. Okay, so before we get started on the workshops, I'm just going to do a quick catch up for everyone else who missed it earlier at the start. What you'll need for today's workshop is you will need VirtualBox, and all the links that you need for this workshop are in, oops, sorry, my screen share paused. There we go. All the workshop links that you need for this workshop are on my repo that I've linked in the chat. And if it's gone a bit past, I'll try and keep them online and in person, Jordan, moving forward. We do have them recorded, worst comes to worst. So I will try and keep a copy of them on our aerospace chat. I believe from Robotics, we're also streaming it on Twitch for all the other users who couldn't make it within QUT or couldn't join us on Zoom tonight. So there'll be copies of these workshops all across for you to review later. Here's the link to the repository I'm talking about. But what you'll need is you'll need an Ubuntu image to work with for today's workshop, mainly because Ubuntu is probably the easiest one to set up with ROS currently. You can set it up with pretty much all the platforms, as I'll go through in a second, but Ubuntu is the easiest and the most versatile so far. So what you'll need is VirtualBox or VMware, whichever one you prefer. We're going to go with VirtualBox today, which is that one right here. Just go into the downloads section on the left, and under downloads, there'll be your operating system that you need. So just download VirtualBox. What VirtualBox is, it's a hypervisor. Basically, it's a piece of software that allows you to simulate a different operating system while abstracting your current operating system away from it. So you can still have Windows and run Linux or Ubuntu or Kali, or you can run Mac OS and still run Linux and Windows on top of that. So it's kind of an easier way without going the dual boot route, which is sometimes a bit more painful because you'll have to work with different drivers and possibly even software issues. Okay, so go through the VirtualBox, download that. Next thing you'll need is the actual Ubuntu image. And the Ubuntu image that we've provided in this workshop is in the second link right there. If you click on that link, it will take you to the VM images that we've linked. And you want to download the one that's most suitable for you. Try and do the dark blue ones, which is the VirtualBox image. If you've got VMware installed on your platform, then use the VMware image as well. And finally, if both of those fail, there is a separate link right at the bottom of the guide, which is the direct Ubuntu install on Oracle. So how you can set it up from scratch. This one's a bit longer, but it sets it up directly from scratch. And if you fall behind in the workshop, don't worry. I've also linked the ROS installation guide as well as the Catkin guide in the second section of the workshop at the bottom as well. So you can still follow along with the workshop while I'm talking through this. Okay, so I'll hopefully get those going in the background while we go through the actual workshop. If you run into issues, just send me a message in the chat. And there's plenty of us in the room. We've got myself, along with Margot, Max, Guy, and Jonathan, who've all worked with these systems and can help you out in setting them up. Okay. Cool. So what's ROS? And what's the whole big term that everyone uses in the industry? And why are we really learning it? The whole reason why we're going the ROS route this year is after a lot of our work experiences and internships, we've found this gap between what university covers and what industry is expecting from you as an engineer or a software developer or any sort of person who works on robotic platforms. And the whole idea behind this series is to try and bridge that gap and give some knowledge to all of us who don't do these units that are higher up in the advanced units. So currently there's only one unit at QUT who teaches this ROS systems, which is EGH 450. and it's also an honors aerospace unit. Other than that, it's pretty much not taught anywhere else. And the whole idea behind this one is hopefully we can all learn from each other and see how ROS is so powerful. So the reason why everyone uses ROS in the industry is it's essentially an operating system. So what it does is it abstracts your hardware from users and applications. And so when you're writing code for sensors, for example, you don't have to worry about how am I going to put all this data back out into a different system that's probably running something completely different. A really good example is the robot that we're doing for robotics right now. We've got a RoboDog project where the platform itself probably will be running in a very high frequency loop, probably somewhere in C and C++, probably also running on a completely different hardware, probably on a GNC computer itself. And then you will have a vision system that's running on a completely different platform, on a different computer, probably running in Python, running some sort of machine learning model on top. Now, these two languages are completely different. They don't generally talk to each other that well, and they're both different platforms as well. So you've got a TNC, a Jetson, probably a Raspberry Pi somewhere in your computer as well. And you've got you need a way of communicating between all three of these while still keeping everything near real time, which is the big problem, keeping things in real time. And with robots, you want to try and be as real time as possible. So that's kind of where ROS stands. And the way ROS works and does all this is using a peer-to-peer network. And basically, if you've done any sort of network so far, what a peer-to-peer network really is everything talks to each other, everything can exchange information with each other, and everything can look at what everything else is doing on the network. And the way we communicate across all the devices is we have some form of master or lead, and everything else in the network kind of listens to the master node and communicates data between each other. So we use a peer-to-peer network, which is what's shown on this graph right here of how a peer-to-peer network works. And you can see that data represented by these dots can be exchanged by pretty much any computer in the system. The way they do it is using a tool-based form where they've got a whole bunch of different architectures within ROS to allow you to do all this step by step. And this is kind of the good image that I found on the ROS website itself, ROS Wiki, which shows all the capabilities that ROS comes with. So it's an ecosystem of different platforms, and every platform comes with its own capabilities and tools. And we'll try and introduce all the tools to you throughout these workshops. So today we're going to be focusing on that very first one on the left, which is, in this case, is called the plumbing, but really it's the entire architecture of what ROS Master really is, and how it sort of goes around sending messages and data across each other. Okay, so this is what ROS is used in the industry currently. You can use it on an Arduino, you can use it on a Raspberry Pi, you can run it on a Windows or Mac OS using terminals and Linux subsystems. You can use them on Turtlebots. Gazebo can use them as well as the Pi operating system and the ARMs that we've seen in EGB339. So if you're doing any of these units, EGB339, EGB439, 445, 446, 345, and 242, you would have learned a lot of control systems and how you can control different parts of the system, but you never sort of get to apply it to an actual robot. And this is where ROS steps in. So with ROS, you can pretty much program in any sort of language that you can think of. Currently, it supports C++, Python, Lisp, Java, JavaScript, MATLAB, Ruby, and a couple more that I can't really think of. But really, there's a whole avenue of languages you can pick from. And that's why it's really powerful, because you can have a front-end web framework running in JavaScript, some form of machine learning model that you wrote in Python, an optimized control system running in MATLAB, and a really fast kinematic model that's running in C++. And everything sort of just slots together nicely with each other. And that's where ROS really shines, because it's a standalone software that allows you to exchange messages from each other in forms of modules. And best of all, it's free and open source. Who doesn't love an open source free community? Is ROS open source? Yes, it is. Where did it originate from? It's from open source robotics, I believe. I can find you the link, Jordan. Give me 1 second. That's the ROS framework right there. And if you want to look at the actual documentation and the open source part, you can find more information at ros.org. I'll link it in the chat for you, Jordan. I'm not too sure about its origin. Maybe Cal can help you there. I haven't dived deep enough to go into the origin of the platform. But yeah, so is everyone sort of on board on what ROS is about? Yep, everyone's going ticks. Sweet. Cool. So we'll get started on the actual platform, but what we'll do is we'll try and get everyone to install ROS first. So that's kind of the next thing I had on my list, which is to do the actual ROS installation. And this is where pain begins if you're doing this on your own, but hopefully we can help you out and set your systems up today to avoid you the pain. Okay. How's everyone going in terms of getting VirtualBox installed? I'll stop share for a second. Yep, ticks, thumbs up. Yes, you can, Jordan. I'll go through that in a sec if you want to know about it. You can do that through a peer-to-peer network. You can run essentially almost everything, in anything that can run on a separate platform. Joe's question, did I miss that earlier?
I was just replying to it in the chat. Joe's question basically was, is it sort of good for loading 3D printers or CNC mills, but not good enough to timing wise to control 2 robots juggling or fast enough to interrupt servo motion? So I think Hud and I are definitely the ones to answer that one, because our entire project over at CSRO was to do with ROS and timing, especially working in real-time systems. So basically, the best thing about ROS is that it's all that sort of middleware. You can have so many different sections going on, and it's actually streamlining the communication between them. So with a lot of real-time systems, you can have an entire system that is working separately, and that can be your true real time. So for instance, your GNC, so your guidance, navigation and control system, can run separately as one big system that has to work in full real time. So for instance, that could be for an underwater robot or a flying robot, but then you can have a different system that doesn't need to be so accurate in their real time, and they can communicate between the two. So you're sort of making sure that your real-time sections that need to run in those really, really fast processes, so C, C++, they run accurately and to speed, but then you can have your backend. So that you're taking the camera images and you want to do some machine learning processing or some data analysis on that data, rather than trying to get it to work in the same time as your really fast real-time system and delay that. You can have that working in the background using the data that's coming from your GNC outputs and straight into your system that way. So it's it's basically the middleware between all these different systems and the communication process between them. That's probably how the best way to describe it.
Thanks, Margot. And yeah, pretty much Margot could definitely explain what the pain was in real time, because we were working on GNC systems at CSR and trying to get underwater robots to pretty much fly in real time and do obstacle avoidance. For those who can't get the VirtualBox running, I have done a separate image with ROS, Ubuntu, and Catkin tools already installed, ready to go. It's just my internet here is not the best, and it's taking a very long time to upload to the server. But once that's done, you can download that and it should have everything set up ready to go for you. So if you can't get it set up tonight, it's all good. We'll have an image that you can pull for the next workshop. Okay, so most of the people did say that they're pretty much ready to go. So we'll get on to the actual ROS installation and what it entails. So if you could spool up your virtual machines, that would be amazing. It might drop a little in terms of computation, so just be wary, because I know virtual machines do tend to take a lot of resources. And I'll try and share my screen again so you guys can follow along. Can everyone see my screen? Also, let me know if my Ubuntu image ends up streaming too small. I've been playing around with the display drivers all day. I can't see my screen yet. Okay. Cool. Now you can.
We can see it now.
Sweet. So the first thing you'll need is, if you navigate to that bottom section of my GitHub, there is a section which takes you to the ROS Melodic install. So what we'll install today is the ROS Melodic software. So ROS comes in multiple different packages. You've got Noetic, Melodic, which are the most common ones that you will hear about. And there's been previous versions, which is the Hydro, as well as the other two that were before them. The most recent one is Noetic, and then from that point on, ROS2 has taken over. We won't be teaching ROS2 today just because it's actually very new. And ROS2 comes with Python 3 support, which is kind of the next push moving forward, because Python 2.7 is no longer supported by Python itself. But for today, most of the robotics that does happen in the industry, Noetic does have Python 3 support, yes. So does Melodic. You just have to configure it. Yeah, so by default, they come with 2.7, but you can configure it Python 3. That's correct. So what you'll need to do the install, can everyone see that, or is it too tiny? I'm guessing that's okay. Then, so what you'll need first up is, okay, hopefully that's large enough. Enhance, yes. Cool. So the first thing you'll need is you'll need to configure your software package and the installation on Ubuntu to allow you to do installs from different repositories. What you'll need to do for that is just go into your Ubuntu software center. Sorry, not that one. So just search up software install, and it's the software and update center that you want to go into, which is the step 1.1 that we're doing. And what you want to do is on that first screen, you want to tick universe, multiverse, and restricted, and hit apply. If it asks for password, just put in Ubuntu, all lowercase, and it should allow you to do it. Passwords for all the Ubuntu systems currently use Ubuntu, so if you do anything with sudo or super user, just type that in as well, although you shouldn't need it much. Once you've ticked those boxes, basically what it allows you to do is it will allow you to basically install from a repository that's not associated with Ubuntu itself. How do I load the image to VirtualBox? Sure. If you've missed it, there's a link on that repository just below it that steps you through Jordan. But you'll just have to go into Ubuntu, go into import, and then import the .vdi that you downloaded, and it should allow you to run it. So if I go back here very quickly, you should be able to go File, Import Appliance, and then import the download that he just downloaded, or the image that he just downloaded. Yes, on the VirtualBox, yeah, not on the image itself. But back to the image. So on the image, once you've ticked those boxes on the center, what you'll need to do is open up a terminal. You can search for it in the Start menu, or you can do the shortcut, which is Control-Alt-T, and that will open up a terminal for you. Make sure you're in the root directory. If you're not, just do CD and then the tilde symbol. It's the curly looking hat. It's the key next to 1 on your numpad. This one right here. I'll put it in the chat as well so everyone can follow along. Make sure you're in the home directory. And once you're in the home directory, just set up your source list to accept packages from ROS. So just copy that line there into your terminal and run it through. And what this will do is it will add the, sure, I'll quickly go to the terminal commands. That's probably a good idea. I'll see if I can increase my terminal size. Okay, hopefully that's large enough for everyone. What CD stands for on Ubuntu is change directory. So I could go into any directory from the terminal itself, and I could also look at what folders I have in my current directory, which is using ls, list directories. And you can see that I've got all these directories. Now, I already installed Ubuntu. I've already installed ROS on this system, which is where this QUT workspace comes from. Which is where you will house all your packages moving forward. But for example, let's go into documents. So I can do change directory, CD into documents, and that will take me into documents. So you can see on the left right here, my path of where I am currently changed to include documents. I could do CD ... which is the shortcut of moving up a directory. Those two main shortcuts that you will see. MV is for moving a file, so I could create a file by going touch test.txt, and if I go and look into my directory right now, so using ls, I can see that test.txt is a file. I could move this into documents, so if I want to move this very quickly, test.txt, I can move it into documents, and if we go into documents, we'll see that that file is now there. Okay, super quick rundown of what it is. Thanks, Toby, for putting that in. If you want to dive deeper into the Linux commands, Toby's put a really good link in the chat for you to follow, which will probably cover them a bit more in depth. Okay, so I'll go back to my root, clear my screen, and we'll go ahead and follow along that tutorial that we were doing earlier. So first thing you'll need to do is just copy that command from 1.2 into your terminal, hit paste and run. And what this will do is it will add the server for ROS into your package list or source list, sorry. And then what you'll need to do is set up your keys. So that's the 1.3. And this will basically authenticate your operating system's connection with the server, so you can actually download the file. Okay. Once you've done those two things, it might take a couple of seconds, but once you've done those two, you've basically established a connection that you can do with the ROS service to get ROS installed. From here on, what you want to do is update your package list. So just do a sudo apt update. and this will get all the latest packages that you can download from all the servers that you've linked in your source list. And once you've hit that, basically what you will end up with is the most up-to-date list of all the packages that you can download from all the sources you've linked. So I've just done an update here. There we go. So it's going through and working through it. 1.3. Do you have curl installed? If you haven't got curl installed, you might run into connection issues. If you don't have curl installed, just do sudo apt install curl. I'll put it in the chat for you. Sudo apt install curl. Generally, Ubuntu does come with curl, but some flavors do omit it out. If that's the case, just do a curl install, and that will have it installed for you. And then after that, once you've got the most up-to-date package list, what you want to do is okay, that's all right, Jordan. What I'll do is I'll basically package up this entire system that I'm currently running. I've already done it. I'm already uploading it right now as we speak. So you should have that one ready to go, and that will have everything set up. Oh, default server for Ubuntu is down. Whoops. Well, I can't help there. No, all good. Cool, sweet. And then, yeah, once you've got the most up-to-date package, you want to install the full version of ROS. Generally, that's usually not recommended, but we'll try and cover as many tools as we can across the series so that we can teach you all the tools it has to offer. So what this will install is it will install ROS, it will install the RQT tools, the RViz visualization tools, as well as the generic libraries and the 2D and 3D simulators, such as Gazebo, that you can use to basically simulate a robot. Okay, so copy that full install across to your terminal. How much storage? We recommend at least 20 gigs. 20 gigs is a good start. Usually you can do with 10, but once you start writing code, you'll need more data. Yeah. So yep, just go paste there and hit run, and it will install a whole bunch of things. And once it's installed what you want to do is follow along through 1.5 and 1.6. These steps are a bit more important, and I'll come back to it because the ROS install will take a couple of minutes. If you're getting system acceleration or USB errors, just go, you can just avoid them for time being. Basically what it's doing is, because VirtualBox is trying to connect to your USB ports directly, it'll be running into port forwarding issues for time being. Don't worry about them for now. We're not going to be connecting any USBs or hard drives to your VirtualBox. Yeah, you can disable them in these settings, correct. Cool. So once the ROS install is done, what you want to do is you want to put the path to your setup.bash in your bash RC. So what bash RC is it's a script that runs every time you open your terminal. And the reason why we want to do this is to basically index our ROS system directory and all the packages it comes from, because you don't want to be going through every time and re-indexing your packages. You just want it to happen as soon as you open a new terminal. So basically that's what this command is doing right here. So it will echo the source of your bash script into your bash RC, and it will basically source it as well after. When we source a file, we're basically running it to get the most up-to-date environment variables back into the system. So just copy that command across into here. And once that's done, basically you're pretty much set with ROS. What you now need is all the dependencies that you need to start developing with ROS. And that's where these 1.6 tools come in. So what you'll need to do is just copy these 3 blocks of code that they've given. Basically, it's installing the Python dependencies as well as the C++ dependencies that you need to start developing code with ROS. And then once that's done, you've got ROS pretty much ready to go. You're set to start using ROS. And then next thing you'll need is the QUT build tools, which we'll come back to in a second. So I'll let you guys install that and keep that running in the background. I will switch over to the PowerPoint so I can explain the actual ROS architecture while we're waiting on ROS to be fully installed. Cool, thanks Max for answering that. Thanks Guy for answering that one. Yeah, if you're getting USB issues, just disable them for time being. We won't be needing USBs or USB port forwarding in this case. Yeah. Cool. If you've got questions, just send them through in the chat and all of us can try and answer it as well. So we'll get started on the ROS architecture. And as the name really suggests, it's a operating system style file system. And so what basically means is it's going to try and abstract all the low-level hardware from a user and all the applications from a user as well. So the good way to think about the file system within ROS is what I've sort of highlighted here, which is everything in ROS comes in packages, which is the top level that we have right here. And within each package, you have a package manifest, some sort of messages that it's going to communicate, a service that it might have, the code you've written, and a whole bunch of other stuff like the CMake file that tell the C++ and the QUT build tools on how to actually build and compile your code. Okay, so like any operating system, it divides all this up in folders and files so that it can abstract the functionality from each other. Okay, so the first thing we'll talk about is what the packages are in ROS and exactly what they mean. Pretty much everything in ROS is built on packages. So packages are basically like the subatomic form of ROS file system. A package basically is the minimum structure you need to make anything in ROS. And in ROS, once you have them up and running, they pop up as nodes. And we'll keep that in mind because we'll refer back to nodes in the diagram when we come back to it. They also have the configuration files, which I was mentioning earlier, which is like your CMake file and things like that, and so on. There's also a package manifest, which is that file, the far left. And basically what that holds is it holds information about your package. Basically what licenses you are running with that specific package. So if you intend to make it open source and public, can people download and edit it? Can people download and distribute it without your permission and things like that? It also has all the dependencies. So let's say you've written a LiDAR sensor node, and for that sensor to work, you might need the Python dependency as well as all the other drivers that the manufacturer's already written for you. So that's kind of a dependency of the package itself. It also has compilation flags. So when you build and compile your code, such as with CMake file, it will basically give it what flags you want to compile it with. Things like, is it GPU enabled? Is CUDA cores are going to be enabled? Things like that, and much, much more. So the package manifest files generally in a XML format, .xml. You might have seen them before in different languages. Basically, it's just a big file structure that lays everything out neatly for the package. And that's a package in a nutshell of what ROS packages are. We'll move into the subdirectories of the package to explore them a bit more in detail. Any questions so far from the audience? I know this might seem like a bit more lecture style. It's just because you need to know the structure before you jump into the code. Otherwise, it's a whole big learning curve. Can ROS run on a Pi? Absolutely can. Want to be an academic? I don't know. I don't think I'm qualified enough yet. Cool. So let's move on to messages and services. So messages are basically a way of communicating, and you can think of nodes and messages as two human beings. So let's say I was talking to Ryan from Aerospace and Robotics. What this would be is Aerospace would be a node in itself. Robotics would be a node in itself, and both Ryan and myself are the people who are acting on the node, and we can talk to each other using messages. We have a way of communication, and that's what messages really are. They're a way of communicating between nodes. It's a topic protocol. So it exchanges information, it sends information to other processes, i.e. nodes, via a protocol called topic. So we'll see the architecture in just a second and what they mean as a topic protocol. But essentially what we have is we've come together and decided on a protocol on how we're going to communicate. And basically we both agree and we'll communicate using that protocol. For example, English is a protocol in its sense. We've all agreed upon this language as a whole. We talk about it all together. And then there's things called services. We won't dive too deep into services just yet because it's a bit more of an advanced concept that we'll revisit in the workshop when we talk about advanced topics moving forward. So I'll just skip on that for now, but it's also another way of communicating between different nodes. Okay. So this is what the computational architecture looks like, essentially. So you've got your ROS master, which is this yellow/gold colored architecture that encompasses everything. And your master is basically what determines what's going to run and how it's going to run. Within the master, you have nodes, and nodes are basically scripts that you write, basically a bunch of code that you'll write. And every node can push data to a topic. And then whoever subscribed to that topic will get a notification and they'll get all that information as well. If you think about it, this is kind of how the YouTube system works. You've got a YouTuber who publishes content and then people subscribe to that content to receive that content. It's the same analogy. You've got a node, for example, let's say a camera. Camera will be publishing images to a topic, and then everything else that's subscribing to that image topic will get those images. For example, you might have a vision node that's running on that camera images. And that way you've got data coming in and out of different nodes. And what this allows you to do is have a 1-to-n network connection. Basically, you can have one sensor outputting things to a topic, but there could be n number of topics that can receive that data all at once. And this is where the beauty of ROS comes in, because you don't have to worry about writing middleware code to try and get data across different scripts, different platforms, and things like that. Once you have a ROS master set up and you have your nodes set up, i.e. your scripts, you basically just start putting data in and it becomes a highway for data to flow both ways. Okay, so this green section is known as the publishing act, and I've done it in green to sort of highlight that. And the orange bit is the subscription act that people do, which are nodes do, where they receive data and do something with it. Okay. Did that architecture sort of make sense to everyone? It's pretty straightforward, but that's why we need to know what nodes and topics are in ROS. I don't see any questions. I'll probably move on. Okay, so what's a ROS master then? ROS master is basically a service that basically keeps track of everything. As the name suggests, it's the master. It keeps track of what nodes are going to be on this platform. It basically gives everything a name. It keeps track of what's subscribing to what. It keeps track of what's publishing to what, and things like that. It's kind of like the main thing that looks after the whole operation. Quite often, ROS masters have lots of parameters that you can set. We will touch into those in the next workshop where we start tinkering with some hardware and how we can communicate different hardwares. And the most common thing with ROS is to command. And the most common command you'll probably use with ROS is the ROS core, which is what enables the ROS master to spool up on your local server. So you might see that I've done an IP address and a port here. In ROS, by default, it runs on your local hosts, and I think it's on port 8855. Don't quote me on that, though. It could be a different port, but it tells you which port it's running at, generally by default. And it provides the essential services that your entire architecture needs. Then we've got the nodes. So the ROS master makes sure that every node is registered before it can be used. And once you've registered a node, i.e. your script, you've got all these nodes that you've basically written up. So a node is basically a single purpose executable program, basically a script you've written. Could be in Python, it could be in C++, Ruby, MATLAB, whatever you feel like. Basically, the idea is it should be single purpose, and that's the key here. You want to try and keep it single purpose, because if you try and do too many things, yes, shout out to Jonathan, who actually taught us ROS right at the start. Yes. But yeah, that's what the nodes are. They're single purpose, and that's the whole idea. Keep them single purpose, and your life will be very much simple, and you won't run into issues. If you need to do multiple things, create more nodes, subscribe to the same topic, and you'll have everything sorted out nice and easy. They're individually compiled, so every node is compiled differently because, as we mentioned earlier, every node might have a different dependency. And they're executed separately as well because they might have different dependencies. Okay? And a node can publish or subscribe to any number of topics. And there's also no rules on how many or how little it can subscribe to. It could just be spooling up and doing nothing as well. Okay, so that's what nodes are. And then finally the topics. Topics, how different nodes communicate to each other. So we saw earlier how the publish and subscription act happens. They happen with a topic command. So we've got a name. A topic's basically a name, essentially, and a stream of messages that everyone can look at. So for example, the LiDAR example again, with a LiDAR, you might have a topic called scan, and then on that scan, you will have a whole bunch of messages coming in that are of laser scan. Basically, it's the scan that your LiDAR did every second. And it will be putting it out, and then you can have whatever you want with it. Nodes communicate with each other by publishing messages. So if you had a node here, your LiDAR, it can publish laser scans to the topic, and then your control system can subscribe to that topic to do whatever it needs to do. It might control the robot, it might control the arm of the robot, or whatever. And as I was saying earlier, the subscription is more of a one-to-N network style. So you can have one node publishing to a topic, but any number of nodes can subscribe to that topic and make use of that data. And pretty much it's almost real time, which means that all your scripts, if they're working perfectly, they should basically be running near real time, unless you're sort of holding the process call somewhere in your code. Okay, so this is kind of what it looks like all together. You've got a ROS master at the top, which registers your nodes, and nodes communicate to each other with a topic. And on that topic, they might have a protocol or a specific message type that the both nodes agreed upon. So here's a quick example on the left that I've put together. A very common one that you might see is driving cars, for example. So cars drive with a velocity. You've got a forward and a rotational velocity. So on a topic named geometry message, or velocity in this case, you will have messages of type geometry twist. And each of these messages would be of linear or angular. And what those would entail is a X, Y, and a Z component in a vector form. I'm hoping most of you've done 126 and understand what a vector form is. If not, let me know and we can try and explain that. But essentially what you will have is at every point you will have a velocity. Let's just say your forward velocity, and you can resolve that into an X, Y, and a Z component. Which is what this vector3 message style is, so this right here is what this green box is. Here, I'll start annotating so you can see it. So this right here is what this message is. This gets published on a topic right there, using the linear and the angular types. So it could be in a linear form or an angular form. And then you would have some sort of drive system. So you might have some drive code right here. Oh boy. You might have some drive code that listens to these topics and outputs motor commands directly to your motor. It might be through a GPIO or an analog to digital converter circuit. That's how ROS messages kind of work in a nutshell. Does that architecture make sense to everyone? And the reason why I'm asking this again and again is because this is the key to understanding ROS. If you can understand this, you've kind of overcome a big hump. This is why it's also really difficult to understand. Okay, I don't see questions coming in. Cool, so this is the entire ROS master process that I just had in the previous one. You can prioritize different processes, yes, Toby. You can prioritize processes as well as execution time. And that's all done by a good friend here, the ROS master, which keeps track of all the nodes. It's very customizable. It's just, you have to tinker with it. So there's this thing called scheduling and node timing and scheduling, which you can configure on the ROS master to say, hey, I want to prioritize my drive command over other things. Cool, so that's basically the entire ROS master architecture. Let's try and give it a shot. Let's do it on our own and see what we can do. So what we'll try and do is a simple chatterbox example. Hold up. My slides, come on, there we go. So what we'll do is we'll do a simple chatterbox example. Very simple, it's kind of like the hello world of ROS, as many call it. And basically what we'll do is we'll create two nodes, a talker and a listener. And the talker would publish to a topic and listener would listen on that topic. And we'll talk over the topic of chatter and we'll use the message type string in this case, basically English and strings instead of binary and numbers. Okay, so that's what we'll try and build today and see how it goes in the ROS system. So before I jump into that, what I'll do is I'll stop sharing my screen and try and help everyone out to get ROS set up. It's just about 7 o'clock, so that gives us about 20 minutes to try and still help everyone out to get everything set up, ready to go. So if you've got questions or you're struggling, put your hand up and we can help you out. Because I'm sure there's many of us here who might be in that same boat. Everybody's so quiet. You're getting an error when you try to install curl. If you can output the error onto the screen, that'd be great. Or you can share your screen.
Yeah, when I'm trying to install curl, it's literally coming up as unable to acquire the front end lock. Or something about resource temporarily unavailable.
Yeah, you got to switch your region on your Ubuntu install on VirtualBox. I had the same issue. It's defaulting to the US server and that particular one's down at the moment. If you switch it to any of the Australians, it's fine.
Yep. It should be in the update and software. The very first thing that I opened up on my Ubuntu. Let me see if I can open it up.
Where would I go to find to be able to do that? Sorry.
Yep, just give me 1 sec.
It should be in the software. 1 second,
Yep.
so I can find it.
Software and update. Here, I'll share my screen so you can see it.
You should say
Sure.
download from, and then you got to pick the drop down.
Yeah, right there. So if you go onto your Ubuntu menu, I think it's called, and search for software and update, it's that one right there.
Is it called software, Ubuntu software or just straight software and update?
You can get there through Ubuntu software, like the orange shopping bag.
Yeah.
And then you go to the top left on the drop-down menu, and there'll be software and updates.
Mm-hmm.
Yep.
Cool.
Okay. I'll just click other.
I'll just go server for Australia. It's probably the best to use for now.
You click on other, and then it comes up with the different countries.
Oh yeah.
I think I'm using the mirror.internet.asn.au/pub, and it's working fine.
Sweet. Thanks, guys.
No problem. Anyone else? Jen, yours is not vibing. Let's have a look. What's it doing?
Not good stuff. So I did I'm way back at the beginning because this is
Okay.
very new to me.
That's all good.
But I opened it and then I wrote in the sources list thing because I just assume it doesn't copy and paste.
Oh, you can copy and paste.
How does that work?
Jen, do you want us to run through it with you?
Please.
Sure. Yeah, I'll bring it up again. So the way
Are you
you can
pasting
copy.
from Windows to Ubuntu?
Sorry, what's that,
Are you,
Max?
are you trying to copy and paste from Windows to Ubuntu?
Yes.
Oh, okay.
Yeah.
For that, you'll need to enable a whole bunch of things. Just
Mhm.
open open it in the Ubuntu system itself.
Yeah,
Make
just use
sure-
Firefox.
Yeah.
Wait, you can do that?
Yep. There is. Ubuntu is an entire operating system, so it's same as Windows. You can open things. So you've got a Firefox already installed on Ubuntu that we gave you. So you should be able to basically copy this from here, and then on your terminal, just right click with your mouse and go paste, and it will have it pasted.
Oh, wait, hold on.
You can't really control C, control V. You go like right click and click paste.
Yeah.
Yeah.
Or in the
Sorry.
terminal, you can also middle click and paste, I think it is. Because
Middle click
that's
or
normal.
yep, or shift and then
Shift and
insert.
insert. Shift
Yep.
insert.
That's where keyboard people are.
Oh my goodness.
Sweet. So hopefully that helps you out. Anyone else?
Oh, my problem was after that though.
Okay. You can share
Oh.
your screen if you're
Hold
stuck
on, let
with
me
it.
see if it worked. Oh, it worked this time. Okay.
Cool. Are you struggling with virtual machine settings, Anthony? Feel free to share your screen if you're still.
A little bit.
Well, yeah.
Okay, let's see what we can do. Share screen. Screen 1.
I saw a few people join in just then. For those who've just joined in, I'll send a link in the chat for you guys. We're basically following a GitHub repo that I've put together. I'll put it in the chat for you so you can follow along. But it's got all the resources. You'll need a virtual box to run the Ubuntu machine. And once you've got the Ubuntu machine, on that Git repo, there's a ROS installation guide that we're following to get ROS installed.
Am I actually sharing things at the moment? Or is
Yep, I can see a screen.
Can you see a
Yep.
screen and the Oracle VirtualBox Manager?
Manager?
Yep, manager, yep.
Okay, cool.
MATLAB installer in the background and everything.
Sweet.
Cool.
So
Cool. Mm-hmm.
settings.
Mm-hmm.
You got these little arrows down here. One of them's USB,
Okay. Mm-hmm.
and the OK is grayed out. I can switch that off, and that gets rid of that warning.
Mm-hmm.
But then we've got hardware acceleration, going to system acceleration, hardware virtualization. Those are
okay.
yeah, hardware.
Mm-hmm.
Yeah,
Disable
so
that?
for that, yeah, for
Nothing.
that particular one, there's a very annoying and very specific issue. It's really bad how they explain that error. But as far as I can tell, for some operating systems that you want to virtualize, you do kind of need to have virtualization enabled, basically.
Yes.
Um,
The way you can enable it is if you do a restart and go into System BIOS, under Interface, there is a virtualization setting that you just have to enable. Sorry, I jumped in. Okay.
In
yeah,
my
it does.
actual BIOS,
That's what I was going
as
to
opposed
say.
my
Yeah.
virtual machine BIOS.
No, like
No,
your
for your
actual
actual
PC.
desktop computer. Yeah.
Not all CPUs have that from memory.
This
Most
one
modern
should.
ones
Is it-
should. You'd
This
have to
one
be
should.
pretty old if it doesn't.
Yeah.
Sweet. That is all I had.
Sweet, cool.
Cool.
But yeah, if you don't want to do that, just wait around until I can upload the other image,
Nice.
and I'll try and help out. Yeah,
Continue on.
cool. Anyone else?
Actually,
Mhm.
if I'm installing on a Raspberry Pi,
Mhm.
does it need to be 180405 that we're working with? Ideally?
Yes. Ideally, yes. 0405, yes.
And that does have a desktop version? Just
Yep. Yeah. So it does have a desktop version for 18.04. It's you might I think from when I did 450, they recommended Ubuntu Mate because it was a variation that was a little bit more compatible in some ways, but it also had its own issues. I'd probably recommend steering away from it and just going with regular Ubuntu on the Raspberry Pi, because I believe they do actually have an image from the Raspberry Pi website you can download to get it installed.
Sweet.
Can I share my screen so we can get to know?
Yeah,
Yeah, go
absolutely.
for it.
I will quickly just check it's not fixed itself. Yeah, okay, it hasn't. So I'm again back at the beginning. Can you guys see my screen?
Yep. Okay.
So I'm getting this.
Yeah. So what you want to do? Go to try change network settings. Change the top one to NAT. Just
Yeah,
NAT
NAT
right at the top.
Why
And
can
it's
you
going to be
not
all
click
weird about
OK?
it. You might need to shut it down first because Ubuntu,
Yeah.
VirtualBox is really weird about changing settings like that when it's running.
But how do you save it? It doesn't let you OK.
You need to
Yeah,
restart
exactly.
your system first. Can't
What's
make
that, sorry?
changes while it's still. You can't make changes while it's still running. Got to shut down the Ubuntu first.
Where's network?
Yep. NAT. Cool.
Still
Oh.
can't click OK there.
Oh, is it doing that?
Try close and open Oracle, VMware, or VirtualBox, whatever.
Yeah. If it doesn't want to play the game, try double checking the error messages at the bottom there. You might have that same virtualization thing going on.
There we go. Oh,
I don't think I can still click.
For your network, OK was enabled.
What was that, sorry?
If you go back to your network, OK was enabled then. Just go enable network. Cool. It's set to NAT, which is good. Just hover
What is
over
what is that error with the yellow? Board. Emulation, that's fine. Yep, you'll need to turn on virtualization on
Turn it
your
on or off?
motherboard as well.
I just turned it
No,
off.
you need to turn on the enable features. So even if it doesn't want to try to use it, it still needs to have it enabled for some.
Yeah.
So I have to restart my computer.
Yeah, pretty much. Yep.
If you go into BIOS, there'll be a virtualization option.
I already
It's
had
the
that
link.
anyway. I will wait for your image then, Rad.
Okay, cool.
Yeah.
The link that Toby sent in the chat is really good if you want to read through how you can make it available. Thanks for that, Toby.
I was getting another error, unfortunately. It's just unable to locate the package for when to install a ROS melodic desktop.
Okay.
Melodic desktop. For some weird reason.
Share that. If you share a screen, I can probably help.
yeah, I think I went through this too.
Okay, let's see.
I know it's locate.
Sure. You able to see that?
Yep.
Yeah, check your settings that Hard was talking about before. Was it software and download or something?
Yeah, software.
Within VirtualBox.
Yeah,
Yeah.
within VirtualBox. So on your Ubuntu machine.
Oh yeah, on the Ubuntu machine. So
Yeah, because
Software
there's
and updates.
if I can jump in for a second, I did see a GPG error on your.
Did.
Yeah, couldn't. get to the GPG error there.
Check your other software tab.
No, ROS is enabled.
Okay.
Check your network adapter. So on the actual VirtualBox manager that you had open,
Yeah.
see if you're sitting on the network adapter. Yeah, so you need to shut your computer down and change that attached to NAT. Yeah, so you need to change that to NAT, but you'll need to shut your Ubuntu machine down first. The VirtualBox doesn't like it. You usually don't have to shut it down because it's just changing the network adapter, but for some reason, VirtualBox doesn't like it at all. It's just annoying. You run into a whole bunch of other issues if you don't shut it down. This is a process that I've gone through many, many times. It's years of pain. For ROS, is that Bill? Yes, just type in ROS on your terminal and it should come up with the ROS manual or the options for ROS. I'll go through that in just a second because you'll need to install Catkin tools as well. Yep, that's fine. If you go OK. You didn't shut it down. Just do a reboot, sudo reboot.
Or reboot.
Just type in the terminal, sudo space reboot. Yep. Cool. Hopefully that will get you up and running.
Fingers crossed.
Okay, I might grab the screen share from you and I'll try and work through the Catkin build install.
Yep.
I think most of us are up to that stage now. Or if not, almost there. Cool.
Tasty, yeah.
Okay. What was that, Jordan?
Sorry, keep going.
Okay, cool. All right, cool. So the next thing you need on that list is the Catkin build tools. 1 second, let me just log back into my Ubuntu machine. So once you go through all of this and you set up your bash RC script and you've installed your dependencies, what you'll need to do next is configure your environment variables. So for that, what you need to go into is that second link I had in the GitHub repository. And if you don't have it, you can get to it by going to ROS installation, melodic, and then Ubuntu. I'll just put it in the chat as well, actually, so everyone can just sort of copy and paste. It's this link right here, configuring environment variables. It's the last link on the Git repo. Basically what this will do is it will configure your Catkin workspace and it will enable the ROS packages across your entire subsystem or entire system, not subsystem, just the Linux system. So to get to that, we just go into tutorials, installation, and then configuring environments. There we go, the first one right there, installing and configure your ROS environments. That one right there. That's the link that I sent. So first thing we needed to do was install ROS. We've done that. We can check if ROS worked perfectly by printing the environment variable on the screen. So this will tell us if ROS is configured in our system. So if I print that here, what this is doing is looking at all the ROS environment variables within the system. And we can see that we've got a ROS master running at local server at 11 311 port number. Sweet. So that means that ROS was installed properly. We can see the distribution of ROS we have is melodic as well, which is what we just installed. So I would recommend doing that check on your system. Make sure that you can do that. And if you can't, you'll have to go into environment variables and just send a message in the chat and we can help you out. But if that works, then what you need to do essentially is source your bash file. So that command right there. And where it says distro, just replace it with melodic, like they've shown in the example here, which is kinetic. And then finally, with all that done, we're ready to set up our Catkin workspace, which is where all those packages that we saw on level 1, which is, if I go back to the image, which is where all of this will live from now on. So we'll create a Catkin workspace where all these packages can stay and be compiled into. So what we'll need to do is create a Catkin workspace directory. That's what this first command is doing. So if you copy that across, paste it, and then go into the source directory that you just created. And once you're there, just hit Catkin make. And what this will do is this will initialize the Catkin build tools within your system. Basically, this is how we'll be building all our packages. The old version was ROS build, but this is now legacy code and people have moved on to Catkin now. Sure, I can put that in the chat. Basically, we're going print environment and, well, not that one, sorry. There you go. That will print the environment variables for you, Max. You can use 2004, absolutely. For 2004 though, Noetic is the recommended ROS version. Melodic is recommended for 1804. Yep. So if you install Noetic, it's the exact same setup, just different drivers written for a different part of the software. That's all. The entire architecture is still exactly the same. Cool. Okay, so now we've built a Catkin workspace and we've done Catkin make. And this is where what we were saying earlier comes into play. So Melodic, when it was first created, was designed with Python 2.7 in mind. It does support Python 3. And if you want to build everything from now on with Python 3, instead of this Catkin make command, run Catkin make with a Python dependency executable set to your Python 3 environment. Before you do that though, just make sure you do have Python 3 installed on your system. And you can do that by just checking Python 3 -- version. And it will tell you if it's installed on your system or not. Similarly, if I do Python, this should tell me what Python 2 version I have. So if you want to configure with Python 3, that's the command you want to use instead of the Catkin make. Once you've got that set up, what this will do is this will create a second bash script under your development folder. So if I go over to my Catkin workspace now, so there we go, Catkin workspace. Under Catkin workspace, I've got my source directory, which is what we created. And then when you do Catkin make, it creates a Catkin workspace configuration file, as well as build, which is where all your code's compiled, and your develop folder, which has the bash script setup.bash, which basically sets up your terminal so it knows where to look for all the packages. And the reason being is you can have multiple Catkin workspaces in your Ubuntu system. Generally, people recommend sticking to one, but you can have multiple different Catkin workspace. you can make one for each of your projects, which is how generally I do it. So if I was working for aerospace right here, what I would do is I would have one for all the UAV challenge that we were doing. We would have that in a separate Kakin workspace. And then if I was working on the RoboDog project, I would have that in a different Kakin workspace because they both have different dependencies. Okay, so once you've done that, basically you want to source the bash file, the setup.bash file from your development folder. And once you've done that, your terminal's all set, ready to go. But to check if it's working, just try echoing the ROS package path. And if it gives you a valid package path, that means that Katkin was able to locate all your packages. And now you're basically set to write some code. So while you guys are trying to install that, I will spool up my example that I've written for the Chatterbox and show you what we are trying to do, and hopefully explain what we've been learning up until now. So first thing I'll need is my ROS master, which I can call using ROS core. There we go. We've got a master ready to go, and you can see that it's running on localhost and port 11311. Cool. So that means we've got a service that can now register different nodes, and it can allocate what's going to be subscribing and talking to different things. So let's have a look if we have any topics. So I'll pull up a different terminal. Let's see if we have any topics, and we can look at topics by looking at ROS topic and then list them. And we can see that the only topics we have is ROS out. These are by default from ROS. It's actually a service that ROS core runs. And basically it's just a internal topic that you can see when errors occur. I'll try and zoom in so you can see. I will give that a shot in a second. Zoom in. Hopefully you can see that now. So let's spool up our two nodes. So I'm going to go into my Katkin workspace, source my develop file so that I can actually look into my folder and see all the packages I have. And now we'll do ROS run. So ROS run is a utility that allows you to run a node by itself. So we'll run a ROS run, and we'll basically get the talker node running. Okay, so that's our talker node, and this is going to be our listener node. As you can see, once you start running ROS, you will need a lot of terminals. And if you want to work with multiple terminals, Terminator is a really good application that allows you to have multiple terminals open at once. So let's do Katkin workspace here and source our file and ROS run our listener node. Cool. So as soon as I start these nodes, we should be able to see the chatter topic that these things are publishing to. So if I run this, there we go. We've got this node starting to talk, as its name suggests. If you look at our topics, we can see that chatter now has a topic, meaning that this thing is publishing to the chatter topic. That is ROS core. And now we can finally turn on a subscription, so we can subscribe to that topic, and we can see this topic is saying, I heard hello world, or hello ROS world in this case. Basically what we have now is we've got data going from this node into a topic. So we've got data going from our listener node, our talker node to a topic. and our listener node is getting that data and showing it on the screen. Or in this case, it's showing it, but we could do anything with it. We could run a motor with that command. We could run a vision system. We could run a control system, anything you want. So that's kind of the example we'll code up tonight. This is just showing you an example of how it works, so you can see the final product. And if you wanted to have a look, we can go into ROS topic echo. Basically, we'll have a listen of what's being published on Chatter. So we'll pretend that we're subscribing to Chatter and see what we can hear. There we go, Chatter. And we should be able to hear what this thing is publishing. So we can see that it comes in as a string. We can see the data type right there. It comes in as a string, and it's hello ROS world, and then the time that it's been running for. It's pretty neat. So now we've got two separate things running simultaneously, communicating data, and everything is running pretty much near real time. We didn't have to try and configure things. We didn't have to try and take data from one thing to another. ROS kind of handles that for us. Okay. So let's kill everything and see how we can code this. Before we jump into coding, I'll just ask everyone, how's everyone going with Catkin build install or Catkin tool build tools install? Thumbs up, cool, okay. If you get stuck, do let me know. All right, we'll jump into the code then, if that's the case. What I'll do is I'll open up the code in I'll just show you the code for now, and then we can write the code itself to see how to do it. So first things you'll need to do is we'll need to create a package for this to work, right? So let's go ahead, clear all this, and let's start making a package. So first thing we'll need to do is go into our Catkin workspace, and all the packages you make, they live under the source directory, this src. Basically, that's where all the code and all the development happens. So let's go into src or your source. And you can see I've got a beginner's tutorial, which is what I was just running to show you guys. So let's create one ourselves. So let's go Catkin create package, give it a name. Let's call this workshop 1 for now. And we'll give it a ROS.py dependency as well as standard messages. And that will create a package for us. So if I ls, you can see that we've got a workshop 1 package. And basically, it's got a dependency of ROS.py, which basically means it's going to be dependent on Python. And standard messages is just a whole bunch of default messages ROS comes with, which has the string message that we use to talk between different nodes. Okay. Let's go into that workshop. So let's cd into workshop 1, and we'll see there's nothing there other than source. So let's go ahead and create our content in here. We'll create a directory called scripts. So we'll do mkdir, make directory, and then scripts. And this is where we'll keep all our code. So let's go into scripts for now. We'll see it's empty. There's nothing there. You can do ls to make sure. It should be empty. We'll start writing code in here. So let's just go touch talker and I'll open it up in an editor. Cool. So that's basically created a Python file for us. What I'll do is I'll open the one that I had written previously, just so I can walk you through. And I'll upload this code on the GitHub repository so you can pull it down as well. Just because this is more teaching how ROS works rather than a coding workshop. So yeah. Let's go into scripts and I'll open up my version that I had. Okay, that is tiny. It's annoying. Can't zoom in. Okay, I guess we're going to Nano. Nano, by the way, is just an editor that Ubuntu comes with. So you can see the code a bit more better. Okay, top part is just the license that it belongs to, and the actual code is down here. So what we have is this first line, which imports ROS.py, and that's one of the dependencies we installed when we installed ROS. Basically, that's what enables Python to talk to ROS master. Then we have the string message type that we're importing from standard.messages. So as I was saying earlier, standard messages are a whole bunch of messages that ROS comes with by default. And we're going to use the string message so that when we publish data, the topic knows that it's coming in as a string. And then what we do is we define a function, or in this case, a callback, as many people call it. Basically a function that can run on this node, what this thing will do. So first thing we do is we tell ROS master using ROS.py that we want to publish data to the chatter node, or topic, sorry, in the type of string. And the queue size, you can think of it as kind of like a buffer, how long you're gonna do the queue for. And then we initialize the talking node, which is this thing itself. Basically, this thing is registering the node. So I'll put some comments in here so you can see it. So tell ROS master that we will be publishing to topic. Register ourselves as talker node and at what frequency we'll be running at. So we'll be running at 10 Hertz. And then basically we've got a forever loop in here. Basically, while the ROS master is alive and it's not shut down, keep printing hello ROS world, and then we get the time of the current ROS time. And then all we're doing is we're getting the login info, we publish that data on the publisher, that publisher that we told ROS master we'll be publishing on, and then we sleep for the time we need to match our 10 Hertz. And that's about it. That's kind of how you start publishing data. And then this bit right here is just a inbuilt Python utility you can use that tells Python that if this is the main file that gets executed, then call the talker function, which is that one there. And that's how we write the code for publishing data. Similarly, you can write a code for subscribing. So we'll look at subscription next. So if I close out of this, and we'll go sudo nano listener. Same thing, we've got our license at the top. And then we've got the code at the bottom so that we can actually subscribe to something. So again, first thing, we've got ROS-Pi, which tells Python that we'll be working with ROS, and it's the utility or dependency we'll be using. Then we import the message type that the both nodes are going to be talking on. So we import that we're going to be doing this over a string. And then we define a callback. Basically, a callback is something that gets called every time a topic has a new message. So as soon as the talking script publishes a new message on chatter topic, that callback will get called in the subscription topic, or subscription node, sorry. And so what we'll have is, we've got a callback here that basically says, I heard, and then whatever data was published on that topic. And then we have a listener that we've defined, which is just a function in this case. And basically what we're doing is we're telling ROS master what we'll be doing when we spool up, or when we become alive, what will be our task. So we tell ROS that we're going to be a node named listener, and that we're subscribing to the chatter topic. And every time something gets published, we're going to do the callback, which is this callback right here that we defined, which gets called every time there's new data. And then that's it. We do the ROS spin, which basically tells ROS that you're ready to go and keep the node running until you exit. And then the last bit of code is just the code that spools up the listener topic. Any questions on the code so far? If not, I'll keep going. Cool, no questions. Okay, so once you've written your scripts, the last thing you need is you need to tell ROS that, hey, these things are ready, can you please compile them? And the way you compile them is using your packages or your CMake list. So let's go back up a directory, and you'll see there is a packages.xml, which basically holds the metadata of your package. Remember how we looked at it in the slide, that every package has a package manifest, which holds the meta file and the nodes or the code that you've written, and the message types, which we already specified, which is string. And the other section is the CMake file. So let's go ahead and update the CMake file. So we can see we've got a CMake file right here, which basically tells the Catkin build tools how you're going to build these things. So if I open up that, the only thing you need to write in here is you need to find the packages of ROS-Pi, standard message, and C++. This will already be written for you by Catkin. Catkin does this when you did the Catkin make, so you don't have to worry about it. The only thing you need to add is, if you go further down, all of this is already pre-written for you. You just have to uncomment it, that's all. That's why you can see that it's a lot of code. It's not a lot of code, it's kind of prepared, ready to go. You just have to uncomment the sections you need. The section we need to uncomment is this one right here, which says mark the executable Python scripts for installation. That's the section we want to uncomment. Basically, we're telling Catkin to install Python, and we're saying the programs that Python will be needed for is the talker script and the listener script. And we're saying once you've compiled it, put it in the Catkin package bin, or where all the packages live. And that's it. Once that's done, that's all you need. I'll put that in the chat for you so people can follow along. Uncomment Catkin install Python section in the package. Cool. Once you've done that, you're pretty much set, ready to go. So you can hit Control X, CD into or CD back into your Catkin workspace. So in my case, it's from the home directory. You can see we've got source and we can now compile. So we can say catkin make, and that will compile all the code. There we go. It's basically building everything in the sense. Oh yeah, it's just complaining because workspace one doesn't follow the convention. That's fine. But now we're ready to go. So we can basically run the code that I was showing you earlier. You can run ROS core in one of them. You can ROS run the talker script, ROS run the listener script, and you will have both of those communicating data across each other. So just to show that again, if I run ROS core in this one, and I'll open up the the talking script on this one. So I'll go ROS run and the tutorial, the package name that you called it. So in your case, it would be workspace one, I think it was, we called it. Yep. And then the file itself, which is the talker.py. And then the last one you want is your listening script. Not that one. There we go. The last thing we need is our listening script, and that's going to be listening to you, subscribing to your topic. So let's just clear all this, and we want to go ROS run, and then the listening script. Cool. And then once you hit enter on both of them, they should be ready to go. So if I hit enter there and hit enter there, we should see data going across each of them. And I know it's not that fun. It's just because we're in a lockdown and I didn't bring out any sensors with me that I can interface with my system. But once we're back at uni, we should be able to get some cool sensors and output some really cool data. And we can look at if the topic exists. So we can do ROS topic list, and it will tell us that they're both communicating on the chatter topic. So I could do ROS topic info and then chatter. It will tell us that on this topic, we've got the talking script publishing and the listening script subscribing to this topic. To answer your question, Toby, can you run ROS master as an actual server and have other nodes such as Raspberry Pi or laptop connected to the ROS server? Yeah, absolutely. And that's what 450 makes you do. So 450 has a ROS master running on a main computer, and then you can have all of these running on completely different computers. As long as they're in the same network, either through Ethernet or Wi-Fi, they should be able to communicate with each other. And that's why it's so powerful, because as you can see on this section right here, I'll try and highlight it for you. So this bit right here, that ROS master, you can actually change ROS master by changing the environment variable in your Ubuntu system. So you can say, hey, I've got a computer connected on this network at 192.168.1.172, and that's going to act as the ROS master. As long as they're in the same network, they should be able to communicate, and the 172 device will be a ROS master. Yep. Okay. Did I lose anyone? Because I feel like I might have. Does anyone want me to go through a specific section again? I'll stop my screen share so I can help everyone else out. How's everyone going? Yes, that would be correct. ROS 2 is actually quite good. I haven't had a chance to try ROS 2 yet. No. I've tried it once at work, but everything at work is still on melodic. So yeah, I kind of had to stay at melodic. Windows 11, I'm still trialing it out. So far, it's a bit of a I hate it, I like it kind of situation. Some things are nicer, some things take a bit more time, and I'm not really. Windows 11, sure, that's the new UI that Windows is doing. And if you go to my desktop, it's the new Windows Home that they've designed. I think they're going more Mac style, where
Do you like that sort of middle part at all that they're kind of copying Macs with?
That's what I'm saying. Like, I think they're going towards a bit more Mac, and I don't know. I don't hate it yet, so it's all right. I didn't know why they needed that though. Like, exactly. You should leave it there. You had a question earlier, didn't you, Jordan? One sec. Okay. What did you say earlier? Can the subscriber comment or talk back to the observer? Yeah, you can. The subscriber can publish things on a topic as well. And then the person who was publishing can receive data back. Although that would be on a different topic. Yes, they are adopting Linux into the Windows, which is something I'm keen to try. So if I open up my Windows system, right there, they've got a entire Linux section now. Oh, wait, sorry, I'm not sharing. Hold up, there you go. Yeah, on Windows, they've got an entire dedicated Linux section now. With Ubuntu and Ubuntu 18.04. So I'm kind of keen to try that out, see how that goes. Win.get. I don't remember using that utility. What's that utility for, Toby? Is it like apt.get but for Windows? Yeah. I don't know. Here I can fire up my terminal and see if that exists. Get. Oops. It's thinking, maybe. Oh, no, searching for help. Nope, doesn't exist. Oh, okay. No, hold up. Winget install source search. You can. That's something new. I'm going to have to explore this further. Okay, for now, let's get back to the workshop. How's everyone going? Do you need hand with anything? I'll upload the 2 scripts and the CMake file. Yeah, all the subscribers can see it, Jordan, to answer your question. So if I bring up that architecture again, actually, right here, and let me share my screen again. So usually what would happen, come on, oh, I don't want Firefox. Usually what would happen is, because this thing's publishing to that one topic, all the nodes that subscribe to it can see it. But now if this node wanted to, let's say, talk back, you could have a second topic, and excuse my mouse drawing, that it can publish to, and then this thing can subscribe to it to receive data back, and that would be like a full cycle. There's things called services that do that as well, which we'll cover a bit later. Yeah, you can think of it as putting files in a network folder, yeah. So this is kind of like your network drive, essentially. So you can put things there, and then everyone who subscribe to it can see what's in that network file or the topic per se. Any more questions? Installation helps, or did anyone actually try writing the code? Or is everyone just kind of secretly waiting for me to push the code to Git? Yep. Okay, well, I might as well push it up now so everyone can see it. I'll make a subfolder in it so that you guys can copy it and run it. Give me 2 seconds. But yeah, in the meanwhile, if you guys have questions, feel free to ask. Do people want the slides as well? I can probably push it up as well. Is used in UAV/drones? Yes, it definitely is. 450, going back to ETH 450, that entire unit makes you use ROS for UAVs and autonomous control. And yeah, it's used out in the industry as well quite often. Anything where you want to customize specific actions, ROS can definitely help you out there. Cool. All right, that code should be pushing up very soon. You should be able to pull it from there. It's under Workshop 1. I'll also put a link in actually. One sec. So you guys can follow along if you wanted to. Save. Okay, repo should have all the details you need. Sorry, I wasn't keeping track of the chat. Okay, let's see. Yes, that would be great. Cool, I'll upload them as well. Yep, I think guys are asking that question. What else do people use? ROS is kind of like a thing on its own, generally speaking, because the reason why it was built is all the developers in the robotics and engineering industry kind of found this as like a common issue. And so everyone's basically gone ahead and worked on this project with open source and made it open source so everyone can contribute to it. I haven't come across anything that really mimics the same file structure and architecture as ROS. You can probably get by writing everything in Python and then compiling it to C, but yeah, that's kind of as close as I've gone, which might be similar. Yeah, I think I'll answer your question, Toby, right there. Yeah, compiling Python to C, yeah, PyC. Yeah, there's already libraries out there that let you compile to C directly from Python. How extensive is ROS itself on the operating system? In terms of like resource intensive, is that what you mean, Jordan? It depends. If you're publishing a lot of data, it could get pretty intensive, but that's why that hertz that we set when we do publishing, that's what kind of mainly is there for. So ROS will always try and keep those refresh rates very close to, if not exactly what you specified, and try and keep those running around the same time. So it tries to allocate time and memory and adjusts it over time based on data coming in. Sweet. Could someone confirm if they got the code? It should be on the repository. Yep, code's up there. Sweet. Yeah, so if you pull those two files, obviously you have to move them to the script folder that we did and update your CMake file to include the path that you put the files into. But once those are done, just hit compile and you should be good. Would the Python to C compiler work on bare metal? I think that's more of a Guy question. What do you reckon, Guy? You're kind of more an embedded person. Is Guy still here? Oh yeah, he is. Assuming no NumPy. I don't know. I haven't tried that, to be honest. Like just on bare metal. I would assume so because it also depends on like what sort of contribution of compiling you're using to compile your code. Sorry, what distribution? Sorry, not contribution. MicroPython. Isn't the whole idea behind it is to make something that can run pretty much real time? I haven't tried it, no. It's on my to-do list to do something at some point. I need to get myself a Pico board and then work on it. Yes, it's a very long list. So it'll happen someday. No problem. Hope everyone found it helpful. Thank you. I tried my best. It's probably the first time I'm presenting this content after learning it myself. So hopefully it helps everyone out. I'll make the slides available as well. And yeah, welcome to ROS. We'll try and do some actual hardware next week, hopefully, once we get back into uni. Thank you.
I got a quick question before we go.
Yeah, go ahead.
I'm just trying to boot up the system again, but it's not quite working in terms of going past the login page. Is that a known bug, or is there another way around it?
Try
it's
sharing
getting...
Make sure and see. Yeah, I'll try and make the recording available as soon as I get a copy of it. Margot Jetson's already set up. I did that last time. Okay, not listed.
Like it would normally you got the two sort of users here, but it's not coming up at all. Is that a known bug, or is there a way around it?
I don't think it's a bug. I think it might be to do with the amount of resources you've
allocated the machine.
Yeah. So if you shut the machine down and add more RAM and probably even a bit more processing power, yeah, it should be able to go through. Yep. See you guys hopefully in person next week. So yeah, try and allocate it a bit more RAM. I would say at least 4 or more if you could. Like it seems like you've got 16. I'm running mine with like 10 gigs of RAM because it loves to consume it. And yeah, probably do like four processors. Yeah.
4 processors.
Yep.
That should be right.
Try, yep. Okay, and try giving it a start again.
This way.
More better, sure.
Yeah.
Yeah, I mean, it really comes down to like if you've got more resources, sure, allocate it and it'll make your life a bit easier.
Oh yeah.
Bye.
Does take its time to boot up though.
Yeah. Oh, is it the first boot up?
No, it's booted up a few times already.
Okay. It's weird. That shouldn't be doing that.
It was doing it before, and I had to I deleted the entire virtual machine and just re-downloaded and installed it.
Okay. Try hitting the Windows L key and see if it brings back the lock screen.
That sends me right to the sort of my lock screen.
Oh, okay, your lock screen. Okay.
Yeah, it doesn't.
Yeah, that's weird. Okay. Well, I'll
Alright.
upload the image and try downloading that one. Hopefully that one's not so corrupted.
Yeah. I'll give that one a shot. Like, it was working fine before, it just went after I shut down the machine and then rebooted it.
Mm-hmm.
It just doesn't reboot again.
Because it looks like it's stuck in the bootloader.
Yeah.
And there could be a whole list of reasons for that.
Oh yeah.
Yeah, I'll try and make my one available. I'll see how good the upload's going. Let me check. Was the workshop pretty fast paced? Because it's the first time I've given it, and I don't know if it was too fast.
It was fast paced, but I mean, like, it was more of just the waiting times of everyone's different connections in terms of stuff downloading.
Yeah, and I originally planned on having my image uploaded, but I didn't expect a lockdown to happen and then my internet to be so crap.
Yeah, pretty hard to say whether it was fast paced on my end or not. But, it sounded all right. I just couldn't get things functioning.
Yeah, hopefully, well, I'll upload this image and hopefully everyone's got the image. And then what we can do is we can start off with the Chatterbox example again, and then, we can continue from there next week.
Yeah.
What I might actually look into, because I have noticed that a lot of people, it's probably quite a few people here, are actually getting issues with virtualization and motherboard BIOS settings and stuff. But that's more with VirtualBox itself than anything else. What I'm looking at doing is getting a quick tutorial, or I'll make up an image of it so that it can be installed on a USB of a reasonable size, like 32 gig or something. And then as long as you can pretty much wipe out the contents of that USB, you'll be able to put an image onto it just using an image writer that I'll also provide. And you'll be able to pretty much replace the contents of that USB with an entire Ubuntu install. And then you can just boot up from that natively. And then I guess just run Zoom on your, phone or something.
Yeah. There are problems though with that, unfortunately. On older laptops that might be okay, but I know at least on my laptop, which is about a year and a half old at this point, you need to disable some sort of Intel Microsoft security option in your BIOS, but then doing that had the potential to needing to wipe your Windows install or whatever, because of encryption or whatever.
Oh right.
Yeah, it's like to do it might even do a secure boot, but a different version of it. Because I know just normally turn off secure boot won't do that, but it was some setting that I needed to turn off, but it had the potential to mess with Windows. Would VMware be better?
Yeah, in those cases, I would say so. I would say
VMware probably is a bit better in that regard. I agree. It's just VMware is a bit more advanced. It's got a lot more customization options. And we were everyone's still sort of starting out. It might be easier to go VirtualBox because it does a lot of things for you.
Yeah.
VMware is definitely an option. And if you guys want, we can probably upload a document on that repo on how to do it with VMware.
It was kind of interesting that during 349, they got us onto using VirtualBox and installing the Ubuntu Mate image to get ROS happening and using that as a base station. But then I think they completely scrapped that idea because we didn't use it at all, and they gave us an extra Raspberry Pi 4.
Okay.
So I'm not
Yeah, they pretty
sure.
much just replaced it entirely with, oh, hey, let's just stuff all of that and let's just make it native because they had weird network issues and things like that. So yeah, it was great.
So, Marty. Hope you enjoyed it. No, I think it also might be to do with the network adapter, because a base station running on a virtual machine is probably not a good idea if you're going to run a ground control station on it.
Yeah.
Just wondering, is there potential to, like, even if you use like Will's or my computer, use it as kind of like what the uni's got, just so people can log into, multiple people can log into instances of Ubuntu?
Yeah, I mean, you can set yours up as a you can set yours up as a supervisor that looks after all the hypervisors. I think it's called a hypervisor or something. But yeah, no, that's a possibility. It's more, can Australian internet handle it?
Yeah. Well, my internet's generally pretty good. But yeah, it depends on everyone else's.
And the other thing is we probably have to check with your internet provider, because that's basically opening up a port on your side that traffic can come to. And a lot of internet providers don't like it, because that's kind of getting into the realms of hosting, which technically falls under business instead of personal use.
Fair enough. Yeah, I kind of just gave up with VirtualBox Ubuntu because I couldn't connect to any of the Australian server pretty much, so I've just reinstalled Ubuntu onto my computer. And now I've got ROS installed.
Oh, nice.
So I'll have to go through those steps later on that you had.
Well, they're all on the Git repo, so it should be all documented. And if you can't find a specific thing, just let me know and I'll add it on. Cool. See you, Andrew. If you still keep running into issues, just message one of us on the Aerospace Messenger chat, and I'll forward the link to the actual event and the Git repo once the files, once the image is uploaded. And that should be a bit easier for everyone.
Yeah.
Cool.
And
thank you.
Hard, you're also reachable through the QUT Robotics Club Discord, because I'm pretty sure Andrew's on that one.
I'm on there as well, and Aerospace is getting a Discord as well, so
very
we'll hopefully be on there.
We can definitely help you with that.
Yeah, like we set it up the server today. Cool.
Very nice. Awesome, guys. Thank you very much.
Thanks.
Yeah. Bye.
Bye.
What? Oh, see you, Jordan. He left as well.
Yeah.
Cool. Is that Toby?
He does not know.
I didn't know that. I knew Toby came in for a bit in the middle because he was sending me messages. All right, I might as well stop the recording because it's going to take time to process. Any last questions that we might want to record? Or
no, pretty good.
Cool. All right. Well,